Hello, David Kennedy here. It's 14th of the 9th, 2021. This is take 5. I'm feeling really tired, but I'll have one more go at trying to get this across. What I'm trying to do is demonstrate that the meter is used to calculate different versions of pi when the meter is 39.375 inches. I'm going to use 3 versions of the Cubit in this calculation. And the Cubit divided by the meter gives 1/6 of pi. So to calculate pi, we need to multiply the Cubit divided by 39.375 by 6, and in this instance we're getting this number here, 31104, which obviously isn't pi. So we do a second calculation on the second Cubit that's created by this model, and it happens to be 20.61818. So we divide that by 39.375 and then multiply it by 6, and we get Fibonacci pi. And we check that by taking the Cubit, dividing it by pi, and we get this constant diameter 6.5625. Now, I want to show you what this model actually is. So I'm going to put the number 1 in there, because every number in this model is dependent on that one cell, the Giza sphere. So when the Giza sphere is 1, the Cubit becomes 39.375 imperial inches. Now there are 6 Giza spheres in pi, so pi is 6, which obviously it can't be unless there are extreme circumstances. And the 7 Giza spheres are 10 barleycorns. Now the important thing to realise here is this left-hand column. So this is the base of the Giza pyramid. We know there can be 70,000 Giza spheres in the base. The Cubit is 39.375 because I've put 1 there. So that's obviously grossly overstated, the value of 1. Because we don't want 1, that's the cube. We want the size of the sphere inside the cube. That's what we're looking for as the Giza sphere. Now, we calculate the Earth's circumference by multiplying the Cubit by 1200, and it gives us circumference in miles. It doesn't look like it does here, but it does actually. And then we can calculate it in feet by multiplying by 5280, and then in inches by multiplying by 12. And we can calculate it in eclipse units by dividing that by 14.66, and look at what we're getting here. 20.412 and 20.6181818. And that's when we put 1 in there, and we don't want to put 1 in there. We want to put, for starters, 20.4 divided by 39.375. The reason we're putting 20.4 in there is because this is the shorter base 99 tom Cubit. So let's see what happens. Nothing, because I've missed out the plus. Right. So there are 2 important numbers here. First of all, we've got the 20.4 Cubit we have to have, because we put 20.4 over 39.375. So the 39.375 cancel out, and it produces a Cubit here. Now, multiplying by 1670, we get 35904. And if we divide that by 4, we get the Aubrey circle, 89760. It's 897.6 feet, but we're getting the same number. And if we divide that by 0.99, we get 9066.66, and if we multiply that by 4, we get 36266. That's the metric version of the Giza base. And the metric version of the cubit is that. And we're getting pi by dividing that by 6, sorry, by 39.375, and then multiplying it by 6 to get pi. And when we divide that by that, we get 0.625, which is always the diameter on this second metric cubit. So we're not getting pi here in this instance, we're getting it here. As we move up in the size of the cubit, this value tends towards pi, and this value will tend to overshoot pi. So let's look at the second unit, which is 20.412. And this is Charles' unit. And we've got 3.1104 as 6 Giza spheres equals pi. Now if we divide that by 0.99, we get 3.1418181818 recurring, which is golden pi, Fibonacci pi, and something that Charles has talked about. And look at what we're getting here, 36288. We're getting 20.412 there, 20.61818 there. So this assumption that we're making that we can find real pi by dividing the cubit by the meter when the meter is fixed is standing up, because we've got two workable versions of pi now, and we're going on to the third one, which obviously is going to give us the base 100 Giza sphere. So we go plus 20.625 divided by 39.375, and there's the Giza sphere, and there's pi as 22/7, and we've got pi here as 3.174, so it's a big overshoot, but we're still getting this diameter, this fixed diameter. This is all metric, and we're getting all the numbers that we're expecting, especially their U, which is 1080. We're getting 1584, 132, 25,000, 20.833. But these have always been calculated by me in imperial inches, and they're not in this case. But these are imperial inches here. And the cubit is the royal cubit in this instance. The Giza height's 5775. And we know that that can be reconciled to the Mayan unit. So I think we can safely say that the cubit divided by 39.375 can give pi. And just as a last calculation, we can put pi in from this program to give us an idea of what we should be looking for when we use this method, and we divide that by 6. and we put that in this cell. It's interesting because we're finding this version of pi, which is obviously the version that everybody's familiar with, and we can see that it's giving a close approximation to 36666.666. The reason for that is because obviously we're using a scaled down version of pi, and in the metric system we're getting this slightly shorter version of 22/7. And what it means is when we use 22/7 we get 25,000 there. So to find out what's happening to get real pi, we can work out how many feet we need to take off the great circle. So we just go plus 132, 123, 123 minus this. So it's 53108.5492. Imperial feet need to be taken off the great circle to give real pi. Now we can divide that by the mile. So it's 10, just over 10 miles is giving real pi. So what happens when we take 10 miles off? Well, we should get 24990 here. (5236) pi is 3.1416. It's bringing us to 24990. I don't think there's much doubt that this is what the designers were doing. It's very complicated, but I hope that I've shown you how this is working, because we only need to put one entry in this model to produce pi, to produce the Earth's circumference in miles, to produce the 99:100 ratio between imperial and metric, and we've got this constant diameter in the metric system when we divide the cubit by this version of pi here. And we know that when we tend down towards the shorter cubits, then this version of pi goes sort of off the scale, it's too low. And when we move right up the scale for the length of the cubit, this version of pi goes off the scale, it's too high. But in between, they're hitting this version of pi that they want to use, which is 22/7. And in this case, they're using a version of pi that they're familiar with, which is 3.1416, and that happens to be 22/7 times 2499 divided by 2500. And that's it for now. And thank you for listening, and I hope that you managed to follow that.